Suppose say you have a radioactive source. Okay, let's take anything, radon, polonium or uranium, whatever it is. Now, how do we understand that it is a radioactive source? Like we need to have certain, you can say that there has to be certain amount of ways of detecting it, correct? And also, once the radioactive decay occurs, then we are going to have a product, correct? So what radiation is going to give you what product? Because you guys already know alpha, beta, gamma rays, and you have also learnt about the properties of it. Now what exactly happens during an alpha, beta and gamma decay? Let's understand that one. Okay, we'll start with alpha decay. Now in an alpha decay, what exactly happens is you have a parent nucleus, and once the alpha particle disintegrates, then the new particle or the new product, we call it as the daughter nucleus. So from parent we get the daughter nucleus. The daughter nucleus will have mass decreases, or the mass will be decreased by 4 parts, 4 units, and the atomic number will be decreased by 2 units. Alright. So in an alpha decay, mass reduces by 4, atomic number reduces by 2. So this is the mathematical reaction. See, X is the parent nucleus, Y is the daughter nucleus, and we know that an alpha particle is a helium nucleus, correct? So helium gets, it's ejected, or you can say helium comes out as the reaction, alpha particle plus energy. So Y, what you are seeing, this is the daughter nucleus, and Q is the energy what has been dissipated. It can come out as heat, kinetic energy, or any other forms of energy. Generally, heat and kinetic energy are the 2 forms of energies. See in an example, uranium disintegrates into thorium. See the mass difference and see the atomic number difference. Okay, so you can see that, right? So this is an alpha decay. Now, how do we calculate the disintegration energy, the value of Q? That energy disintegrated or the energy dissipated, that we can calculate with the help of Einstein's mass energy equation. So we get Q is equal to mx minus my minus mass of the alpha particle He into c square. This gives you the energy which has been dissipated because of the alpha decay. Fair enough? The second type of decay is a beta decay. Now beta is what? Beta is fast moving electrons. Remember, during that class, during that particular video, we were talking about how an electron gets disintegrated from a nucleus, because inside the atomic nucleus there is no electron. There are no electrons inside the nucleus. You only have protons and neutrons. So from where are we getting electrons? The 2 fast moving electrons. We'll come to that. Alright. Now what happens in a beta decay is that the mass number remains the same, but atomic number increases by 1. Let me tell this again. Mass number remains the same, but atomic number increases by 1. Okay. So how we write mathematically, X is the parent nucleus, and now you have Y as the daughter nucleus, and we are going to eject one electron, and of course you are going to have energy. Okay. Now what exactly happens? Let's come to that. See, in beta decay, a neutron which is there inside the nucleus, neutron disintegrates. Now a neutron has a life of 3 minutes. In the sense, outside the nucleus, neutron cannot exist by itself for more than 3 minutes. After 3 minutes, the neutron is going to disintegrate, and then it disintegrates into a proton and an electron and an antineutrino. Antineutrino is a type of a subnuclear particle. We are not dealing with that right now. But what you know is that neutron disintegrates into a proton and an electron, correct? Now, this is why the atomic number increases by 1. Because see, atomic number is what? The number of protons inside the nucleus. So, we are adding one extra proton, isn't it? That's the reason the atomic number increases by 1, but mass number remains the same. So, that electrons what we get is not the actual electron, in the sense not the outer shell electrons, but it is the disintegrated neutron which is converting into electron. Look at the example. Thorium is converting into protactinium. This is a beta decay. Now remember, whenever we talk about beta decay, an anti-neutrino will also come out. Okay, anti-neutrino. So neutrinos are subatomic particles, actually subnuclear particle to be more precise. Subnuclear particles, they don't interact with anything. Okay, they don't interact with anything. Every second, probably billions, if not billions, probably trillions of neutrinos pass through our body. Like literally. But then we don't feel anything because they do not interact with anything. So one type of subnuclear particle is neutrino. But here we are going to get antineutrino. Okay, this is a beta decay. Coming to the last one, gamma decay. Now, have you noticed in one of the properties of the alpha or beta decay, and also one of the laws of radioactivity, I specifically told you that after an alpha or after a beta, we are going to have a gamma decay. Correct? Always alpha and beta, whatever it is, you are going to have a gamma decay. There is a reason behind it. What exactly happens is, see, once there is a radioactive decay, the daughter nucleus will be in the excited state. That excited nucleus has to come down to its ground state. Correct? When it comes down to the ground state, that's where the gamma ray is dissipated. Or you can say the gamma decay occurs. So here, no change in atomic number, no change in mass number. See, as you can see in this particular reaction. No change. That star, what you are seeing, that is the excited state. And once it returns to the ground state, now gamma is released. Alright, that's what I was telling you. After a beta or alpha or beta decay, gamma decay will occur. Okay, let's see an example for this one. Let's start with after one particular decay, like alpha or beta or whatever it is, then we'll come to that, okay? Look at this particular reaction. See, you're seeing series of reactions, correct? One cobalt is changing to nickel and all those things. First, understand what type of reaction this is. Is it an alpha decay or is it a beta decay? That's the first thing what you guys have to understand. Okay, now you know what type of reaction this is. This is a beta decay, correct? That means the daughter nucleus is in the excited state. Look at the second equation. In the second equation, the daughter nucleus is in the excited state. It releases gamma ray with an energy. The energy is also given there, correct? And further, in the third reaction, the daughter nucleus, which is in the semi-excited state, it comes to the ground state. Once nickel comes to the ground state, again it releases energy. So this is what we call as gamma decay. So three types, alpha, beta, gamma. In alpha, mass number reduces by 4, atomic number reduces by 2. Beta, mass number remains the same, atomic number increases by 1. But in gamma, no change in any of the mass or the atomic number, but energy reduces. Okay, these are the three types of radiations what we can get from the nucleus, or these are the three types of radioactive disintegrations. Okay, now since you know what it is and everything, let's try to understand about fission and fusion from the next video.